Alright, today we're going to finish our chapter 1.6 notes. We're going to do example 6 and example 7 together. So example 6 has us plotting the complex number in the complex plane. So you guys are familiar with the Cartesian coordinate plane where our y-axis is up and down, our x-axis is side to side. This is, the complex plane is using the same idea. You're going to use the same kind of way you move on these coordinate grids. But now our y-axis is our imaginary numbers, and the x-axis is our real numbers. So if you look at part A here, A is 3 minus 2i. So the 3 is our real part, and the 2i is our imaginary part. Negative 2i, I should say. So that means, starting at 0, 0, our real part we're going to go over 3, and then the imaginary part we're going to go down 2, and this is our A. So imaginary is up and down, the real part is left and right. For part B, my real part is negative 2, so from my origin I'd go to the left 2, and then up 7. So up 2, 4, 6, 7. So my point would be right here. For part C, this is a pure imaginary number, so there's no real part. So that means I'm not going to move left or right at all. I'm just going to start at the origin, go up 3, and I have my point C. For D, I have my real part is negative 4, my imaginary part is negative 8i, so I go to the left 4, and then I'm going to go down 8. 6, 8. So that would be my part D. And then finally E, this is a purely real number. It has no imaginary part. So I'm just going to go left and right. I'm not going to go up and down. So from the origin, I'll go over 9 to this point right here, and that's my point E. So that's plotting complex numbers in the complex plane. It's not too earth-shattering, but if you have any questions, further questions about it, let me know. So then the other thing that we want to talk about is the absolute value of a complex number. So the absolute value of a complex number z equals a plus bi is denoted as absolute value z, is a non-negative real number defined as absolute value of z equals the square root of a squared plus b squared. This is the distance between z and the origin in the complex plane. So this is actually this specific, so if I'm looking at point D, it's this specific distance here. You might recognize this is, if you drew this as a right triangle, right? This is your hypotenuse, and that formula is just the Pythagorean theorem solved for your hypotenuse. You might also recognize it from geometry. That is your distance formula. So we're going to use that to find the distance between a complex number and the origin. So example 7a wants us to find the absolute value of negative 4 plus 3i. So what you're going to do is you're going to write this out as negative 4 plus 3i, but I want to point out this is just a notation. We're not doing what you did in Algebra 1 where you have to split this into a positive solution and a negative solution and solve. There's nothing like that here. All you need to do here is write, this is our notation, sort of like f of x is our notation, right? And then you just plug it in. It said that it's equal to the square root of a squared plus b squared. So my a here is negative 4. My b is 3i. So it would be negative 4 squared plus 3 squared. Notice you don't need an I here. You don't need an I for a couple of reasons. Mostly it's because an I squared is negative 1, and we don't want this to be negative. When we square something, it should be positive. So we just want to drop it. When you do that, then you'll have the square root of 16 plus 9, which is equal to the square root of 25. Since this is a perfect square, we're going to simplify this into a whole number, an integer value. If this was not a perfect square, you would need to go back to your 1.5 lesson, and we're going to simplify it. You'd make that factor tree, divide it by your perfect squares, and simplify the radical. But in this case, 5 is our whole answer. So part B, we want to find the absolute value of negative 3i. So this is equal to, notice here I have no a, so my a is just 0. My b here would be negative 3 squared. I'm going to warn you again, your calculator, if you just type negative 3 squared into your calculator, it will tell you it's negative 9. Your calculator is interpreting that as a negative 1 times 3 squared. You'll have to use parentheses if you really don't know it, or just remember that a square should be positive. So we have the square root of 9, which is equal to, again, this is a perfect square, so it's just equal to 3. On your homework assignment, you have several that are not perfect squares that you'll have to simplify into a number times a radical, like we did in section 1.5. So if you have any questions, let me know. This concludes our chapter 1.6. If you're not going to be here on Friday, we're having a quiz on Friday over 1.5 through 1.6, so expect to come back to that quiz whenever you're back in school.